introduce actually a very good personal friend of mine, one person who I've worked with for many, many years. Jimmy Pike is a chief architect at Dell, and he's going to come up and talk a little bit about all the things that Dell is doing to contribute to the Open Compute project. So Jimmy, come on up.
So we live in exciting times. I'm really excited about the technology changes and the things that are occurring. I want to spend a little bit of time talking to you about some of the historical perspective of where we've come from and the future, and how we're going to, by the way, I will tell you, keep those old textbooks because you may need them again. Because we're doing some of the same things over and over. If you look back, when I first started out, I'm not going to talk about when that was, but mainframes were the rage. Well, that was great. And, you know, the whole idea about a mainframe was this non-stop machine that we created, and it had a complete management solution, a complete management suite in it. Everything was about keeping it up and running. In fact, you could argue that the mainframe was all about the management. And then time progressed, and things went on a little bit, and the mini-computer emerged. And the mini-computer was really doing mainframes, but doing it with cheaper complements. And you did more of them. And, you know, they had a big impact into the mainframe, and we saw mini computers come along. Then there were the RISC servers that emerged. And the RISC servers absolutely killed the mini computer. You know, they went the way of the dodo bird. They were gone. We still see mainframes out there, and there's places where mainframes have a place to play, especially in highly available markets. But the RISC server came along. This was the invention of the microprocessor in the server model. It was the technology that went there, and in many ways it was a disaggregated machine where you had storage, server, CPU, memory, networking, and all these things put together in a way that we could make things out of that were really valuable. Now, the RISC server guys, there were more of them, a small number of deployed mainframes at a company, a larger number of mini computers deployed at a company, much larger number of RISC servers. And RISC servers came along, and they had these custom solutions, especially around management. Everybody understood what their environments did, saw where their values were going to be, and we created these customized solutions to provide management. Then the PC server came along. And the PC server came along and basically displaced the RISC server. You can still see them today, but for all practical purposes, the monolithic motherboard PC server came along, and the RISC servers could not compete with the cost model. So we're in this era today where PC servers are the thing that everyone is looking at. And we have an evolving model as far as storage management goes. For example, in 1988, SNMP was introduced. And it's a widely accepted model for simple network management protocol. Things evolved, and we had IPMI, which was the integrated power management interface. It was not the integrated platform management interface. So today we have the integrated platform management interface. If you go look at the specification, it's 600 pages of optional things that you can do. It's very good about describing how you can do options and how you can do things that you need for management. But everything is optional, and you can do it greatly different based on vendor to vendor. Then we have DCMI come along, and DCMI is a standard which basically tries to go out, and it tries to provide some insight into some things that you need to do with IPMI to create management stability. And now we have the ARM SoC come along. So we're seeing things happen here where there's lightweight servers that are going to be in the same space where we've been. We have the continuing evolution of technologies that we've seen from my colleagues who have presented. We have the introduction of photonics, the things that are going to be required to manage it. And we have these varying ways of doing things. So I don't know how this is all going to turn out, but one thing I will tell you, it's going to be volumes that we have never imagined. The scale of what we're talking about really will boggle your mind, as we already see with some of the larger hyperscale companies. So if you look at where this is all going to go, management and scale, it's all about common commands and responses, and it's a consistent feature in behavior. What you want is you want things that are absolutely essential and are always there and you can count on. So when you go from machine to machine, vendor to vendor, a platform to platform, you can count on those things that you know are there and how they're going to behave. That's all about the OCP management that I'm talking about now is about, those consistent commands and responses. Now, what I'm going to show you here is this is a couple of machines that we brought. This is a Dell PowerEdge 6220. It's built on 4 Intel 2620 CPUs, dual socket servers, and it's OCP compliant. It complies with the remote management platform that the OCP committee has been working hard to do. This is a APM 64-bit ARM machine. It is also OCP compliant. In fact, if you look at the slide that I showed a moment ago, what I'm showing here is I'm showing the Intel PowerEdge system running OCP management compliance mechanisms, and I'm showing the APM 64 running the same software. And they're attached to a PowerEdge switch, and as you look at this, we actually have a desktop that's running IPMI, it's running the IPMI tools to exercise both of these. So what you see here is you see a known tool case that's exercising both an x86 and an ARM-based system. We also have a desktop. You can actually see this in the platform booth. If you go out there today, we'll show it. And we have people who will take you through what this means and how it works. And this is an APM 64 ARM motherboard that fits into our C5000 chassis. And what this is an early concept for a system that has 6 independent servers on a board. And it plugs into that chassis, and it will be management compliant with the OCP standard. So where this is all going is, if you look at the focus of the OCP management, we have the machine management piece, there's the lifecycle piece, how we're going to do firmware, there's the event logging, and the one that's the most further along is the remote management piece, and that's the specification that these are all conforming to. It's at 0.92, and we expect a ratification in it very soon. And then there's, of course, strategic technology as we go forward. So, with that, I would also like to show you this. This is something we call Project Sputnik. This is a Dell Xps 13. Now, this one is special in that it has Linux on it, and it has the IPMI tools on it. So if you want to develop for the OCP management model, you can take this platform with the IPMI tools, and you can recreate the model that I showed in the picture there. So, in summary, if you look at where things are going, the technologies that have evolved, the things that are going to occur as we go forward, we're somewhat repeating some of the same learnings we've had in the past. We had very disaggregated systems. We went to monolithic systems, and now there's a reason for us to go back to disaggregated systems. So I will leave you with this one thought. If you look at the history of things, where we've come and where we've gone, CPU generations continue to come. CPU generations, CPU types continue to come at us. Form factors come, and form factors go. But management lasts forever. So with that, I'll ask you to come out of the door and see what we can do.